Hello everyone. Today we are going to discuss about design pattern. Basically, design pattern are categorized into three parts: creational, structural, and behavioral. Today we are going to discuss a structural pattern. It is called as facade pattern. In the intent, the facade pattern provides a unified interface to a set of interfaces in a subsystem. Facade defines a higher level interface that makes the system easier to use. Here we come to motivation part. The motivation is to simplify the complex system by reducing their overall complexity and minimizing the dependency between the subsystems. By constructing a system into subsystems, introducing a facade object, developers can provide a simplified interface to more general facilities of a subsystem. In the context of the programming environment, accessing a compiler subsystem, the classes such as scanner, parser, program node, bytecode stream, and program node builder can overwhelm most users who simply want to compile code. The facade pattern addresses this by providing a higher level interface through a compiler class, which acts as a facade, offering a single simplified interface to the compiler's functionality. Next, we are going to discuss the applicability of facade pattern. A facade can provide a simple default view of the subsystem that is good enough for most clients. Only clients needing more customizability will need to look beyond the facade. There are many dependencies between clients and implementation classes of an abstraction. Introduce a facade to decouple the system from clients and other subsystems, thereby promoting subsystem independence and portability. You want to layer your subsystems, use a facade to define an entry point to each subsystem level. If subsystems are independent, then you can simplify the dependency between them by making them communicate with each other solely through their facade. Here, this is the structure of the facade. Here we have facade class and there are many subsystems. It will be not visible to the user. It will make the complex system into the simpler one. The participants of the facade pattern are facade, which acts as a compiler. It knows which subsystem class are responsible for a request. Delegates client's request to appropriate subsystem objects. And there are many subsystems classes. Here, these all are subsystem classes. Scanner, parser, program node. In this, we have discussed these in motivation. So we take these as subsystem classes. The subsystem classes basically implement subsystem functionality, handle work assigned by the facade object. I have no knowledge of the facade. They keep no references to it. For collaboration, clients communicate with the subsystem by sending requests to facade, which forwards them to appropriate subsystem objects. Although the subsystem objects perform the actual work, the facade may have to do the work of its own to translate in interface to subsystem interfaces. Clients that use the facade don't have the access with its subsystem directly. In the consequences, it shields client from the subsystem components, thereby reducing the number of objects that client deal with and making the subsystem easier to use. It promotes weak coupling between the subsystem and its clients. Often, the components in the subsystem are strongly coupled. It doesn't prevent application from using subsystem classes if they need to. That you can choose between the ease of use and generality. When we come to implementation, the facade pattern reducing the client subsystem coupling. The coupling between the clients and subsystem can be reduced even further by making facade an abstract class with concrete subclasses for different implementation of a subsystem. Then clients can communicate with the subsystem through the interface of the abstract facade class. This abstract coupling keeps clients from knowing which implementation of a subsystem is used. An alternative to subclassing is to configure a facade object with different subsystem objects. To customize a facade, simply replace one or more each subsystem objects. And the second part is public versus private subsystem class. A subsystem is analogous to a class in that both have interfaces and both encapsulate something. A class encapsulates states and operation, while a subsystem encapsulates class. And just as it's useful to think of the private and public instance of a class, we can think of the public and private interface of a subsystem. The private interface of a subsystem consists of class that all clients can access. The private interface is just for subsystem extenders. The facade class is of the public interface, of course, but it's not only the part. Other subsystems are usually public as well. For example, the classes parser and scanner in the compiler subsystem are a part of public interface. Let us discuss a real-time example of the facade pattern. Now we need to design an application to place an order in an e-commerce application. Here we have place an order method class. We have three classes: product, payment, as well as invoice. In these three classes, we have three methods. In the product, we have get product details. In the payment, we have make payment method, and in invoice, we have send invoice method. As shown in the above image, in order to place an order, first we need to create an object of product class and get the product details by calling the get product needed. Then if everything is fine, then the system need to make the payment. In order to do this, we need to create an instance of the payment class and create make payment method. If the payment is successful, then the system need to send the invoice to the customer, and to do so, we need to create an instance of invoice class and call the send invoice method. So when we need to place the order, we need to do the above mentioned steps. Step 1, creating the subsystems. In our example, the systems are going to be product, payment, and invoice classes. And each class will have its own responsibility. So let's create the three classes and implement their responsibility. First class is product. We have created the name with product.cs. Here we have the class product and method get product details. After the method is in the method, we have printed the fetching the product details. Next, we have the make payment class. Here, after doing the payment method, we will give the print message payment done successfully. These product and payment class are subsystem classes. Now we have to create the facade class. This is going to be a concrete class, and this class takes the responsibility to place an order. So create a class file with order.cs. This class is having one method which will create subclasses object and call the respective method in order to place an order. This is the code for the facade class. Here we have place order method in the order class. We have gathered all three classes and methods in this facade class. First, we have to place the order. It has been started, and we have to create an instance for the product. And we have to get the we have to call the method get product details, and we have to create another instance for the payment, and we have to call the method, and we have to create another instance for invoice and call the method, and finally we should uh, give the print code order place successfully. In the step 3 we have to create the client class. Please, here the client simply needs to create an object of order class and call the place order method which will place the order. And finally, in the client class, we have to create an instance of an order and call the method. The output will be in the facade class, what are the print we have given, it will be the output in the client class. Here place order started, fetching the product details, and payment done successfully, and invoice sent successfully. Hence, we have reduced the complexity in which each subsystem have played a major role and reduced the complexity. We have kept all these things in the facade pattern. Hence, this is the facade pattern. Thank you, everyone.